and then go to my screen. All right, so we're going to look at 8.2 next. And this one deals with graphing polynomials. But we really won't be graphing. We're just going to be looking at them and picking which picture we think we're going to get from these polynomials. So there's three things we're going to look at on these first. So the first thing is the number of real zeros. Maximum. In a polynomial, is equal to the degree. And that's sort of what I was telling y'all a while ago on that x to the third we had. I said there'd be 3 zeros because I knew the degree equaled the number of real zeros. You get maximum, okay? Now it says maximum because sometimes you can have repeating zeros. So if you had one that repeats, then you won't actually get as many as your degree, okay? Number of x-intercepts maximum in a polynomial is equal to the degree. But y'all already knew that. We knew that x-intercepts and zeros were basically the same numbers. So if it's maximum for the real zeros, it's got to be the maximum number of x-intercepts we can have. So this is also equal to the degree. But y'all, this one changes. The number of turning points maximum is equal to the degree minus 1. Just like on the parabolas, we had an x squared, so that x squared graph made a parabola. Its degree is 2. It had 1 turning point. So 2 minus 1 gave me 1 turning point. On the x3 graphs, the x3 graphs come up, sort of turn, and then go back up. Since it's an x3, its degree is 3, it would have this turning point and this turning point. So it's always 1 less than the degree for the maximum number of turning points. Once again, if you had a repeating 0, one of these could be that repeating 0, and you might not get 5 or 6 like a degree, okay? All right, so for this example, for the function, find the maximum number of real zeros maximum number of x-intercepts and maximum number of turning points. Okay. So I'm going to find the zeros max, the x-intercepts max, and then the turning points max. So zeros, maximum number of zeros. Oh, hold on, we need our function. F of x equals x to the 6 minus x squared plus 2. So the degree is the highest exponent, which is a 6. So the maximum number of zeros we set up here was equal to the degree. So if the degree is 6, the maximum number of zeros is 6. X-intercepts, we said the maximum number of x-intercepts was equal to the degree. The degree is 6, so x-intercepts maximum 6. But then the turning points we said right here was equal to the degree minus 1. So my degree is 6. 6 minus 1 gives us 5. So y'all, that's all you're going to do on those few problems, okay? So now we're going to sort of go back. Let me let y'all write that, but we're going to go back to problems using the chart we made a while ago. Even and odd degrees versus positive and negative coefficients, okay? So let me turn over and show you what we're going to do.
Wait, I have a question.
I got you.
For the turning point, Max, how did you get a 5?
Because remember, the turning degrees maximum equals the degree minus 1.
Oh, okay,
so
okay.
The degree was 6. I basically just come in here and just said 6 minus 1 and got my 5.
Oh, okay, thank you.
So these two will always be same, and this is just going to be one less than it on those turning points. All right, y'all. So for f of x equals 1/4 x squared minus 2 choose the correct graph. So I'm sort of going to go through what I know on this and then show y'all pictures, and we're going to pick the one that we think is the one that goes for this function. So first thing I would look at is this has a degree of 2. And that lead coefficient is positive. So you got an even degree, positive lead coefficient. So when it was even and positive, we know that both sides should go uphill eventually. So they're going to give you a picture here. So let me put it right here. So notice, this one goes uphill both sides. This one's going downhill left to right, uphill left to right, and then this one's going downhill both sides. So the only one that could match the picture we came up with would have been A on that. Remember, even and positive, they're both heading uphill, okay? So I use this little chart we just came up with on these because they got what these graphs have to look like in the big picture. So that one, we would pick the graph. We're just going to rough sketch it. We knew we had an X and a Y. And our graph basically just came up like that. And that's probably at -2 because that looks like the y-intercept at -2. So we would probably have that crossing at -2 right there, okay? All right, so same thing on this one. This one has f of x equals x to the fifth minus x to the fourth plus x squared plus 14. So I'm going to go through this. I got a degree is 5, which is odd. There's not a number in front, so we treat that number like a positive 1 sitting there. So the lead coefficient equals 1, which is positive. So remember, if we had an odd degree, positive lead coefficient, left to right, it should be going uphill. So y'all, let's look at these pictures. What we're doing this one right here. So degree 5, lead coefficient 1, we said was uphill. This one's going downhill. This one has both sides going downhill. But if you notice, C is going uphill, left to right, so we would choose C. So I'll sort of draw that in. Okay, so it would have had a turn here and a turn here. This one probably has almost, remember, this one could have 4 turns because that's the X5, okay? All right, so you're going to do a few of those. So I wanted to move down to one like number 9 has on it. So number 9, we're still going to choose the correct graph. But this one will be a little bit trickier to find, okay? We're going to have h of x equals x times x minus 4 times x plus 5 times x minus 5. So it's hard to find a degree when they're like this, so I'm going to show you how I would do that and my lead coefficient. Now, if you wanted to, you could FOIL this whole thing out. I would FOIL these two, then FOIL by that one, and then FOIL that by the x. But that's more than we got to do. All we got to do is multiply all these x's together. That's a 1x, a 1x, a 1x, and a 1x. So x times x times x times x equals x to the 4th. So you would add all them ones together and get 4. So the degree would be 4. And basically, all these x's have a 1 in front of them. And 1 times 1 times 1 times 1 equals a positive 1. So you see what we got? We got an even degree and a positive lead coefficient. So I wouldn't try to FOIL all of this, because remember, that's going to make a trinomial. And then that trinomial times that, you're going to get a big polynomial, okay? I would just multiply all the x's together. So it's even and positive, so we know both sides should go uphill. Okay, y'all? And then you got to sort of, all these had just what, a multiplicity of 1 on them, okay? So they're odd, so they would actually go through the x-axis and all my zeros, even that. All right, I'm trying to see what we want next. All right, so another one like that. And I wanted to do this one because it had a few different exponents on it. I got a negative x times x minus 1 squared times x plus 4 squared. So This 0 happens twice. This 0 happens twice because of those multiplicity. And this 0 happens once. So I've got 5 zeros, so I'm going to multiply all these x's together. So I got, for my degree, that's going to equal negative x times, this is going to give me 2 x's, and this one's going to give me 2 x's. Or y'all could write that out. Negative x minus 1 times x minus 1 times x plus 4 times x plus 4. Okay, either way will work. So how many x's do I got? I got 5, and that's a negative, so I got a negative x to the 5th. Lead coefficient. Well, all these had 1s in front of them, except this one had a negative 1. And notice what that negative did. It made the final answer a negative 1. So I got an odd degree. Degree is 5, which is odd. Lead coefficient is negative 1, which is negative. So remember, when it was odd and negative, it should go downhill, left to right. And that's the main thing you look at, which picture has the overall shape of the graph that you're doing, okay? All right, so I'm gonna let y'all catch that up. And then we're about to learn how to do synthetic division. At least get a start on it. All righty, y'all. So 8.3 is polynomial division. Now, we're only worried about one type of division we're going to use. We're going to be using what we call synthetic division. So we use this instead of long division, okay? So for synthetic division, first thing I do is write out the coefficients of the polynomial. Remember, the coefficients are the numbers in front of the variables. Now, use zeros for any missing degrees. So what I mean, if you have an x3 term, an x squared term, but you don't have the x term there, you got to put a 0 there, and then you got your constant term, which is the number at the end. So write out all those coefficients. Find C, and that's what we're going to divide by. Okay, so C is equal to the value of the remainder. Oh, let's not put all that. This just we're going to find C because it's going to be easy, and there's like 3 different ways to do that, so I'm going to leave that off. All right, so synthetic division is a process, okay? So first thing I'm going to do is bring down the first number. And I'm just going to sort of give y'all a rough idea of what I'm going to do. It's easier to watch it and learn it. All right, bring down the first number, multiply that number by C and put into the next column under the second coefficient. Okay, you'll then add that column and bring number down. And y'all, from there on, repeat the process of multiplying and adding until done. Okay? So you'll see what all this means when we start working these. Anyone still writing? All right. Synthetic division can be used and there's three things I'm going to use them for in this class. First thing I use them for is finding function values. I can do stuff like f of 2 with it, okay? F of 3, f of anything. Second thing I can use it for is to determine if a number is a 0. Then the third thing I can use it for is to find the quotient and remainder. Okay. This is support lesson, does the quotient and remainder part. College algebra, we focus on function values and the zero stuff. So I'm going to do quotient and remainder like support, and then we'll use it for the other stuff. So I'm going to use synthetic division to find the quotient and remainder, if any. So I'm going to use x to the square. Oh, let me see what I want here. Minus 10x plus 24 divided by, so let me see what I want, x minus 6. So this would be what you're sort of doing in support, but it's a good way to show you what we're going to, how to use synthetic division. So the first thing I'm going to do is write the coefficients of the polynomial. So since I got a degree 2, add 1 to that, and that tells me how many numbers I need. Because of that constant term, you always add 1 to get total numbers. So 2 plus 1 would give me 3 total numbers. There's not a number here, so it's a 1. Second number would be negative 10. Third number would be 24. So you write your numbers, and we're going to draw a little upside down box. And y'all, under the last number, I always sort of square that box off. So draw your numbers, and then you can draw that every how. Now over here, I put a little box. This is where C will go. So here's the thing on C. If in factor form, like we got here, then C is opposite the factor in sign. So if you're using it for quotients and remainders and you're given a factor like x minus 6, you change the sign of the negative 6 so that your C is 6. Just like a 0, right? If that's a 0, it's going to have opposite sign than the factor. So what we do, we're going to divide this by our C, which is 6. Now, the first thing I said to do was take the first number and bring it down. So we're going to bring that first number, which is a 1, down into our bottom here. Then I said take that number 1, multiply by C, which is 6. So 1 times 6 is 6. And put that number in the next column under that coefficient. So I multiply by the C, got 6. Then it said add that column and bring that number down. So y'all, a negative 10 and a positive 6 would give you a negative 4. Now repeat the process. This negative 4 multiplies by the 6. So negative 4 times 6 is negative 24. And I bring that into the next column under that coefficient. Add those together. 24 minus 24 is 0. So where the 0 is the remainder. This 1 and negative 4, they're my quotient. But when we write the quotient out, we got to put the x's back in it. And the quotient always starts out 1 degree less than the original polynomial. So this quotient is 1 degree less than the original polynomial. So each time we use synthetic division, it knocks it down a degree, okay, because we're taking out one of these x's, which means this would be 1x to the first, because that's 1 less than that, minus 4. So if you take an x squared minus 10x plus 24, divide by x minus 6, your answer will be x minus 4, and this one has a remainder 0, because I got a 0 in that last box. So y'all, this ain't too bad once you get using it. So in support, remember, they're going to give you factors, change the sign of the C, and then work your synthetic division. Now, I'm going to use it to find function values next. So I want to turn this. So y'all watch this. If using synthetic division to find function values, then the function value is equal to the remainder. Okay, so if I'm using it to find a function value, all I'm worried about is the remainder I'm going to get when I'm done. So y'all watch this. So we're going to, on this example, we're going to use synthetic division to find the function values. given f of x equals x to the third minus 13x squared plus 52x minus 60. We're going to find f of 2, f of negative 5, and f of 6. So that means I'm about to do 3 synthetic divisions. All right, now, when we use it to find function values, C equals the number right here. So my C will be a positive 2, a negative 5, and a positive 6. We only change the sign of C if it's in factor form, okay? So first one I'm going to find is f of 2. So I write my coefficients, which is a 1, negative 13, 52, and a negative 60. Now I know I got 4 numbers because 3 plus 1 gave me 4. So there's my 4 numbers. I'm going to draw my little box. And remember that since the remainder is equal to the function value, what's in that box when I'm done will be the function value. Actually, it'll give me the same number here that I would have got if I'd have put that 2 in for all those x's. Okay? So remember, C, we don't change the sign. It's going to be a positive 2. All right, so you always said bring the first number down every time the first number comes down. Multiply the 1 times 2, which is 2. Put that in the next column under that coefficient. Add that negative 13 and 2. So when you add negative 13 and 2, you get negative 11. And then repeat the process. Negative 11 times 2 is a negative 22. That's going to go under the next column. Add that column. 52 negative 22 gives me what? 30. Repeat the process. 30 times 2 is 60. That goes under the next column. And y'all look at that. Negative 60 plus 60 is 0. So watch this. I can do this. X to the third would be 2 to the third minus 13 times 2 squared plus 52 times 2 minus 60. And guess what? I get 0. So this means f of 2 equals 0. Now, we would bring down the next C would be negative 5. My coefficients are going to be the same. 1, negative 13, 52, and negative 60. And once again, I'm worried about what's in my box. All right, y'all, the 1 comes down. Now, had I wanted a quotient and remainder out of this, since that was an x3, this would be x squared minus 11x plus 30. Always 1 degree less. So 1 degree less than 3 would have been a square, the x, and then the number. All right, y'all, let's go. 1 times negative 5 is negative 5. Here's where I get a lot of people. When you add 2 negatives, it will be negative. And then 13 and 5 is what, 18? So that gives me a negative 18. I get a lot of people that make that positive, and it messes them up, okay? All right, negative 18 times negative 5. That's going to be a positive 90. So that's going to go right there. 52 and 90 is 142. And then y'all repeat the process. 142 times negative 5 is going to give me negative 710. Added to a negative 60 is going to give me negative 770. So if I was to take that equation and put those negative 5s in it, I would come up with this number here. All right, which means f of negative 5 equals negative 770. All right, finally, my last number was f of 6. So I'm going to pull that over here. There's my 6. My numbers will still be 1, negative 13, 52, and negative 60. All right, y'all, here we go. We bring the 1 down. 1 times 6 is 6. Next column, add negative 13 and 6, we get a negative 7. Negative 7 times 6 is negative 42. Oh, let's see what we got there. 52 minus 42, what's that, a 10? And y'all watch this. 10 times 6 is 60. Negative 60 and 60 give me 0, which means f of 6 equals 0. So let me tell you this. If I was looking for zeros for this polynomial here, 2 of these numbers would have been zeros. F2 would have been a 0 because its remainder is 0. F6 would have been a 0 because its remainder is 0. So if you get a 0 remainder, that means that that number was actually a 0, an x-intercept, and all that, okay? So some of these are going to be finding function values, and then some you're going to be checking if that number is a 0. So I wanted to finish up with one more. That's going to be like the last one on 8.3. So we're going to use synthetic division to determine if negative 3/2 is a 0 of f of x equals x to the third plus 5/2 x squared plus 9/2 x plus 9/2. So I wanted to do one with y'all with a lot of fractions in it, okay? So we know our C over here is going to be negative 3/2. We're going to write our coefficients. 1, 5/2, 9/2, and then 9/2. So I needed 4 numbers because 3 plus 1 gave me 4. And then I'm going to write my little box. Now, if negative 3/2 is a 0, then the remainder must be 0. To be a 0. Well, that sounds funny. Remainder must be 0 to be a 0, okay? Now, I wanted to show y'all that this fraction one's not that bad. The first thing is still to what? Bring down that 1. All right, 1 times negative 3/2 is a negative 3/2. And y'all remember when you subtract fractions, common denominator, all you do is subtract on the top, put it over that 2. So 5 minus 3 would be 2, but you got 2 over 2, and 2 over 2 is 1. So y'all watch this. 5 divided by 2 minus 3 divided by 2 is going to equal 1. Then you take that 1 times negative 3/2, and you get a negative 3/2. So these both better match since you've got ones down here making those two numbers. Now, since these got a common denominator, we'll subtract the top and put that over 2. Well, 9 minus 3 is 6. 6 divided by 2 would make that a 3. So here we go. 9 divided by 2 minus 3 divided by 2 is going to give us 3. Now, watch this. 3 times a negative 3 halves. Now, remember, when you're multiplying fractions, negative 3 halves times 3, put a 1 under that and multiply straight across. Negative 3 times 3 is negative 9. 2 times 1 is 2. So when I multiply 3 times negative 3 halves, I get a negative 9 halves. Add negative 9 halves here to a positive 9 halves. We get a remainder of 0. So that would be yes, a 0. Okay, so remember, support, you're looking for quotient and remainders, which is this stuff. So the quotient on this one would have been 1x squared, because it's 1 degree less than the 3, plus 1x plus 3, remainder 0. Okay, so let y'all catch that up. And then that's going to be it for today, y'all. So I'm going to stop this recording.